Hey guys, once again welcome to the session. So now we have to understand about the wireless RF fundamentals. What is RF? This is the major, player for any wireless communication. So wireless communication basically use the RF concept that is known as a radio frequency, right? And without this RF concept, even the communication is not going to be happen. Means the communication, any communication which is going to be happen in the air, that always going to happen in the RF, that is the radio frequency way. So like you might be have seen that concept in very childhood. People are having some kind of the very fine sharp kind of the long what we can say, they have ropes kind of the stuff, right? And by using them they just try to communicate. They say hello and that is going to receive by the receivers as well, some minor sound, and people keep enjoying that. But that was possible to send some kind of the communication from one location to another location via the using the wireless media by using some kind of the rope. Similarly, uh, we have some concept, right, where we have to again exchange the message between these two peoples, but this time we have to continuous send this signal in the form of the waves. Wave means the signal is going to be up and down, up and down, and up and down, and then finally it is going to receive to the receiver. Sender is keep sending, receiver is going to be keep receiving. That is known as sine wave signal method. So basically, this is how the communication was going to be started, and this is known as the radio frequency. So this radio frequency, let me just move to another slide, which having the better representation. So if you go here and if you try to understand about the wireless communication theory, so this RF radio frequency is basically going to measure in the this wireless communication, that is known as the frequency, that is going to again measure the hertz. So frequency is the number of the cycles that is going to be calculated in the per second. So your signal is going to populate from one location to another location in terms of the sine waves. And how many sine waves you are just going to be captured in the 1 second, that is known as your frequency. So number of complete cycle per second means complete cycle. Once you go up and then again come to the zero and then again go down and again come to the zero, that's the complete cycle. So in one like cycles, how many seconds are going to be used means in 1 second number of cycles, how many you are going to take. So in this example you can see in 1 second there is 2 cycles. This is the one cycles and this is another cycle, so 2 cycles is going to be completed. Similarly in the real scenario it might be the more and less as well, and this is going to be measured in the hertz. Measurement of the cycles per second is known as the hertz. So all communication is going to happen in the hertz format, right? Radio frequency concept where the communication is going to be happen. And wireless communication, whenever you just have to communicate with any media, there is a band. So you might have seen that you are just going to listen any radio station, so you have to run some kind of the band 93.5 FM, you have 93.8 FM, 100.06 FM. What are these numbers? These are the frequency band, nothing else. So these are known as the frequency band. Even if for the any wireless communication, mobile communication, also we having the 1800 band, we having the 4000 band, and different band also we have. So these bands are allocated by the government. So if this band you have tuned, you can only communicate, or might be you can only receive the signals. If 93.8 you just tune, you can only communicate or you can only receive the signals. It's not like everyone can receive that signals and communicate those signals. Similarly in the Wi-Fi, there is a two bands has been allocated. Means communication is going to happen in the frequency way, but we having a two band also, that is known as a 2.5 gigahertz band and another is a 5 gigahertz bands. So even you can see in the real scenario also there is two bands. You can see 2.5 gigahertz, this is a 5 gigahertz, and it's a 2.4 gigahertz. If you go in the more Wi-Fi settings, you will see that which band you have connected. So probably let me show. You can see if I just click on this, and here you can go. So right now it's connected on the 5 gigahertz network band, and this is the channel, this is the speed. You can see 585 receive and 688 download, this kind of a transmit and receive signal. This is the MAC address and IP address, everything you can see here. And this is the Wi-Fi protocols, this is opening, this is the security type they are showing. So what is this? This is the band. So if I am connected on the 5 gigahertz, right now I'm connected to 5 gigahertz, that's why it's a 5 gigahertz band. But if I'm going to switch to the 2.4 gigahertz, it is going to show to the 2.4 gigahertz as well. I hope you understand. So in any wireless communication, in regard of you're working from the home, you're working from the office, it's the broadband or it's my non-broadband, these bands are going to be allocated, right? So wireless communication is going to happen between these bands. Radio frequency is going to be used to exchange the any wireless signal from one device to another device through the air, right? Further, these bands are going to divide into multiple channels. And what are those channels? I'll explain this, but you just have to understand these are the bands. CCNA, you just have to understand the band. Further, these bands has been divided into multiple channels. So let's suppose I am in the one band and I need to communicate. So I need some kind of the channels. So you can see this PC is connected on the channels. That is a 44 network channels. So similarly, we having a different channels which is going to be allocated, right? We having a 3 channels in this range, right? And these 3 channels total, we have the 14 channels, but 3 channels are going to be non-overlap channels, right? Non-overlap means if you are doing any communication, there is no interference is going to be happen in this 2.4 gigahertz. In 5 gigahertz, we having the more channels, 20, we having the more channels. You can see 1, 2, 3. So we having a lot of channels here. So if I go here, you can see these are 14 channels are available in 2.4 gigahertz, right? And they are going to be used for different country. And in 5 gigahertz, we having the more channels, and they are going to be used for the, it's a total 24 channels are non-overlapping channels are available here. Just we have 14 channels. Out of these 14 channels, 3 channels are non-overlapping means these channel cannot make any kind of interference, right? So if you see this diagram is also created in such way. Let's suppose I have the 14 channels, right? And I have to give some bandwidth, and how the bandwidth is going to be defined for the each channels. So this is the bandwidth range 2.4 to 2.4835, and you have to keep the ranges, means keep the space of the 300 gigahertz band, right? Similarly, in the 5 gigahertz, we have the range 5.15 to 5.85, and you also keep the 300 gigahertz like the that's going to be range between the bands. So if you just going to draw some kind of the communication, and if you just start transmitting the signal to the all the bands, all the channels, there is a huge interference is going to be happen. So to mitigate those problems, we just have to make sure, like we just have to give the 5 gigahertz frequency. This is the non-overlapping channel, and this is going to be draw such kind of diagrams. In these diagrams, if I am starting from here, it is going to use 3 channels, and I will start the 4, it is going to use till 8, and if I am drawing by 9, it is going to 13. So these all are not going to overlap. We'll understand in later stage what is the concept behind it and what is the mathematics behind it. But in CCNA level, you just have to understand this theoretical concept, how it is a band, how many bands are there, and later probably you will find the more information about it. So IEEE standards, we have different IEEE standard. Even this PPT, you will find that. And initially, when I just started the PPT and we just discuss about the basic SSID and that BSSID, we started with this standard. So this standard you just have to understand, and also we have to know other standards. This is a very basic standard we have. IEEE when just introduce wireless system, this standard was like introduced 802.11. which was just going to operate on 2.5 gigahertz. Okay, but if you want to operate 5 gigahertz, then you require this standard. This is again 2.4 gigahertz standard, but there is differences also. Why I use this, why I cannot use this, why I use this, why cannot I use this. So every bands or every standard having some kind of the great features, and we just have to understand those great features. So highest great feature is the this 802.11x, which is going to operate on the both of the band, and this is going to be give the lot of kind of the features. One more thing you just have to understand about the key features about the 2.4 gigahertz and the 5 gigahertz. These are the bands, and we have to understand these bands, the speed and all. But before that, also have to understand what is a 2.4 gigahertz and what is a 5 gigahertz. So 2.5 gigahertz, 2.4 gigahertz can always be slower, but the range is going to be high, means coverage is going to be high. It's a faster, but range and coverage is going to be shorter. It is going to penetrate, means there is a building, there is obstacle, it is going to cross them, but it is difficult to penetrate. It's a crowded, it's a non-crowded. So in nutshell, if you want to understand in very layman language, so if you're going to use 2.4 gigahertz, your coverage is going to be very high, but the speed is going to be low. But if you're going to use a 5 gigahertz, your coverage is going to be low, speed is going to be high. That's all. This is a basic difference. And now if I talk about the band differences, what is the band differences we have, and what is this frequency band, right? Meaning, so Wi-Fi frequency bands. So if you go and try to understand, so from the Wikipedia itself, so let me explain a little bit. Let me see. It's too much. Let me open this one. I just want to find the crisp definition. So here you can see we having a 2.4 gigahertz, where we having the 3 over non-overlapping channel. USA, different country they have. Okay, so these are the things you can see. 802.11a, as J and AC. These are different things we have. So probably we just have somewhere some table. There are a lot of things that we have. So frequency band, let me see what is exact. IEEE standard. Let me frequency IEEE standard. Let me see this. You can see this table I was looking for. Yes, we find that. So you can see this is the IEEE standard, and if you go down, these are the bands. You can see if you're using this 802.11b, which is the very basic one. Which is the basic one? What is the bandwidth you can get? Maximum 11 Mbps. So you can see, even you are using this B, this is the very basic. This A was also basic. 11 was very basic. It's a very low speed. Even from B, it was defined. You can get for the 11 Mbps. For if you go with the G band, it is going to be give the 54 Mbps. If you go for the A, it's a 54 Mbps again. So this is also going to give the 54 Mbps. If you go for the N, that is 600 theoretical, right? This is also possible. So these are the different if you go for this AC and AX, that is a GPS and the more faster speed you are going to get, because these are the latest one, which is not compiled here, but you'll find the tables also. They having the very good definition how it is going to be look like. So let me go and find that table also. Here we can see that and you can see This is the adopted speeds. These are different like years where this was adopted. And if you go here, see, so in this band you can see 1997 2.4 bandwidth 22 Mbps. This is 22 Mbps. These are different like 5, 10, 20 Mbps. But if you go N 20, 40 Mbps, AC it 1 to 156. You can see that's the bandwidth they are supporting in megahertz. And if you go for the AX, that's even more. So different standard having a different and stream rate. You can see this is the data rate. Okay, so 1 to 5 11 this is going to be 54 20 Mbps, up to this going to support up to 248 Mbps. So this I was referring wrong table, and this is going to happen 693 Mbps. This is even, you can see 96048 Mbps, and it is going to show up to 11.5 Gbps. So the more you are going to be get the standard high, you having the more kind of the feature in terms of the speeds. But most popular we have these tables, which is going to explain each and everything about the bands. So I have that's all for the bands, right? And we just have to understand about the RF and the RF band, and that what is the 2.4 gigahertz, what is the 5 gigahertz, and how they are going to play a very vital role in the communication. The next section I'm going to understand about the different mode of the wireless communication, how the signal is going to be communicated, what is the different antenna mode and all. Okay, so for time being we are good, and let's see in the next lecture where we will do the again deep dive for this wireless section. Thank you so much.